The iOS port is a steep climb, unlike the Android version which maps almost directly to the native code. Still, one of the advantages in iOS programming is the cleaner underlying API that often simplifies common use cases. Due to this, I chose to skip third-party libraries and try to implement the functionality of CameraKit directly on the native iOS APIs. When we use generate native stubs, the iOS stubs include two files, an H and an M file. Let's review the H file first. I'll look at what was generated in both before we begin. This is a standard Objective-C import statement that adds the basic Apple iOS API. Imports in Objective-C are more like C includes than Java imports. This is the class definition for the native interface. Notice that NSObject is the common base class here. The method signatures should be pretty readable, as they map directly to the Java equivalent. GetView expects a peer component on the Java side. From this side, we'll return a UI view instance. Once we get this, the implementation code is more of the same. We import the header file we just reviewed, just like includes in C. Method implementations match their declaration with curly braces for the implementation. Parameter names are important in iOS. If you change the name of a parameter, you will break compilation as the name is a part of the method signature. Most types are familiar, but some, like Boolean, use a slightly different syntax with yes and no instead of true and false. The same is true for nil instead of null. We'll start by bringing in constants from the Java constants interface. In the Java implementation, we could ignore their values in the native side because the implementation already used the exact same values. We don't have that privilege. I'll also add an import to the native AV foundation, Audio Video Foundation, which is the iOS API for media. There are copies directly from the Java code with the public static final portion replaced to const. This will make coding the rest easier. So now that we have the sense of the scope, let's start implementing the important methods one by one. The natural place to start is the start method. For this to work, we first need to define the first time CameraKit launch variable. The first time start is invoked, we initialize the default values of the various constants to identical values we have in the Android version. This method initializes the camera view the first time around. Notice that self is the equivalent of this. Dispatch sync is the iOS equivalent of call serially and wait. We want the block below to execute on the native iOS thread, and we want to wait until it's defined, it's finished. The capture session is stopped on the stop call, so if this isn't the first time around, we need to restart the capture session. Before we proceed to the lazy init method, let's look at the variables we added into the header file. The direction the camera is facing, front or back, whether flash is on, off, or auto flash mode. Focus can be based on point or automatic. Allows for several modes of capture. I didn't implement this for now. A set of constants indicating the resolution for recorded video. Current camera zoom value. I saw yes here if the app was given permission to access the camera. Since some callbacks for video and photo might be similar, I set this to indicate what I'm capturing. This is the actual UI element we will see on the screen. A UI view is the iOS parallel to component. I'll discuss this soon. Notice that I imported the camera kit view class here. It's a class I added, and I'll cover it soon. This is the native capture device representing the camera. A different device instance is used when we flip between back and front cameras. A session encapsulates the capture process. We need to acquire access to the camera with a session and relinquish it in stop. The preview layer is where the video from the camera is drawn. This is a CA layer, which is a graphics surface that we can assign to a UI view. I'll discuss this when covering Camera Kit View. This class is responsible for capturing a movie and saving it to a file. The last two entries handle photos. The former works on iOS 10 and newer devices, and the latter works on older devices / OS. That's a lot to digest, but we are just getting started. Let's move right into the lazy init method. When I started with the code, I thought the camera will initialize lazily, but that didn't fit the rest of the API. So I abandoned that approach and initialized on start. I didn't bother changing the name since it isn't user visible anyway. The content of the following block runs on the native iOS thread synchronously. The method won't return until the code is finished. This is the equivalent of new object in Objective-C. We allocate the object and invoke its init method, which is sort of a constructor. We're asking the AV capture device whether we have permission to use the media device. This can result in one of four outcomes. Not determined means we need to ask for permission. So we ask which should prompt the user with permission dialog that he can accept or reject. If he accepted, we move to the second phase of authorization in lazy init post-authorization. If permission was denied in some way, there isn't much we can do. The user will see a blank view. If authorization was already granted previously, we move on. Notice that for this to work, we need the iOS NS camera usage description constant I discussed before. Without that build hint, permission is denied automatically. Let's move on to the lazy init post-authorization method. This is a complex method, so I'll divide it into two parts for simplicity. The first part of the method deals with detection of the device, meaning picking the right camera. This checks if a specific class exists. iOS 10 deprecated an API and introduced a new one. If the new API doesn't exist, we'll fall back to the old API. If we reach this block, we are in iOS 10 or newer. You will notice that getting a device in iOS 10 is one method, with the only difference being the position argument value. Notice Objective-C method invocations use argument names as part of the invocation. Notice I referred to Objective-C messages as methods. There is a difference between the two, but it's not something you need to understand as a casual Objective-C user. This code is running on a device with an iOS OS prior to iOS 10. Here we loop over all the devices within a vCapture device. If a device is in the right position, we update the device value and exit the loop. The bottom portion of the method is common to both iOS 10 Plus and prior. Objective-C often accepts pointers to error variables, which it assigns in case of an error. I didn't check for error here, which I should. The input object can be created from the device. We need it to start a session and don't need it after that at this time. We allocate a new capture session and set the input value. Preview shows the video of the session in our view. It's a CA layer, which we can't add directly to the screen. SetLayer is a method I added to CameraKit view. I'll discuss that when covering CameraKit view. This is how you show a CA layer within a UI view. These methods allow us to keep common code between the initialization code and the setter methods. That means a call to set flash will trigger update flash internally. I'll cover all 4 methods soon. The final line starts the capture session. This seems like a lot, and it is a lot. We went through the heavy lifting portion of the code, and as you can see, it might not be trivial, but it isn't hard. I didn't know half of these methods when I started out, but that's the great thing about being a programmer in this day and age. We can Google it.